Good morning, good afternoon, good evening, whatever, and wherever you are. My name is Anna Rochelle, and today we are going to do 4 problems from Chapter 12, Lesson 4. This is actually in the Big Ideas Geometry, high school geometry book. This is the Common Core State Standards book, and it talks about the probability of disjoint and overlapping events. So we're gonna get right to it. Okay. So the first question that is given to us by the student who sent these problems in is asking us to find the probability of A or B. And so the probability of A is 3%, 30% or 0.3. The probability of B is 10% or 0.10. And whenever we're looking for the probability of one versus the other, we're actually taking a look at the probability of both together. So what happens is when we look for the probability, I'm going to change this color right now. Okay. What happens when we're looking for the probability of A or B, we're actually looking for the probability of A plus the probability of B. So in this case, I'm actually doing whatever the probability of A is plus the probability of B. And in this case, it's pretty basic. We know that probability of A is 0.3. The probability of B is 0.1, so 0.4 is the probability of either A or B. Done. Now, before we move on to problem 10, it's a word problem, I do want to take a look at this problem because it still says the probability of something or something else. And it's done a little bit differently, okay? So here's the piece that's done differently in this case. So this type of problem is actually a find and correct the error. So we have to kind of like take a look at Homework Simpson and think like Homework Simpson and what would he do in order to solve this problem? And then he'll be like, oh my gosh, I got the right answer. But then, oh, silly Homework Simpson, no, you did not. So we're talking about cards. We're talking about playing cards. And when we look at playing cards, we have a deck of 52. And in this deck of 52, we actually have 4 different suits, right? So if you've never played cards, it's kind of like an unfair question because you don't really know what is in that deck of cards. So the one thing that I've been finding that has been super helpful is actually taking a deck of cards and playing with it and looking through it and just getting yourself familiar with what's happening. Maybe organize them in one way, maybe organize them in a different way, maybe organize them in a third way. And just so that you get to know and really see and understand and get familiar with this deck of cards. So in this particular case, I know that there are 4 suits. The first suit is the hearts, then we have the diamond, then we have spades, and then we have clubs. These 2 are the red color, and these 2 are the black color. Every deck of cards has numbers that go 2 all the way through 10. And then there's a jack, a queen, a king, and an ace. And then there's 2 jokers, but the jokers, there's 2 jokers. The jokers make the deck a deck of 54 instead of 52. So if I were to divide this 52 into 4 even pieces, we would see that we would end up having actually 4, whoops, not 4. We would have 13 of each type of card. Okay, so we have 1, 2, 3, 4, and then 2 through 10 is actually 9. So there's 4 of each, right? And then if we're looking at the face cards, the face cards show up. There's 4 face cards. There's 3 face cards. The ace is not a face card. The ace is just like a 1. Sometimes it's used as a 1. Sometimes it's used as a higher than a king card. Again, definitely, if you haven't familiarized yourself with cards before, up until now, definitely go in and just get a deck of cards and maybe even borrow from a neighbor or a parent or something like that, so that you have the ability to understand and familiarize yourself with that. So we're looking at hearts and face cards. So actually in the hearts, there's also these face cards. So when we're looking for either hearts or face cards, as part of this 25 out of 52 that are either one or the other, it's also included in that section that it's actually both hearts and face cards, right? So we know there's 13 hearts, and we know there's 3 of the heart face cards, 3 of the diamond face cards, 3 of the spade face cards, and 3 of the club face cards. So we need to actually, in order to fix this homework Simpson error, yes, we need to add the 12 and the 13 to get the 25, but then after we get the 25, we need to subtract the 3 that kind of show up in both cases, so that we can get really either one or the other without double counting. So now we're going to be at 22 over 52, and then we want to simplify to 11 over 26. Normally, I would say stick with the fractions. I think the fractions are the best version for probability purposes and just anything in general. I prefer fractions over decimals. Some teachers I have seen prefer decimals for this particular unit because probability is more of a percentage thing and decimals are better percentage representations. So if you need to do that, you can simply just do 11 divided by 26 and get 42-ish percent, right? Or 0.42. Those are both totally acceptable as well. Again, before we get to the word problem, I do want to go through the basic nitty-gritty things, and then we'll get to the word problem so that we really understand what's happening. Okay, so problem 13 actually tells you that you're rolling a 6-sided fair die, and the probability of one event is rolling a 6, and the probability of another event is rolling prime numbers. So one of the things that we know when we roll a die is that our options are 1, 2, 3, 4, 5, and 6. We know that 1 is actually not a prime number, and 2 is the only even prime number. 3 is a prime number, and 5 is also a prime number. So one of the things that we know is that the probability of rolling a prime number is actually 3 out of 6. The other option is, what is the probability of rolling a 6? Well, that's just 1 out of 6. Now, if this problem were very similar to the first problem that we did, we would just add the 2 and simplify as much as possible, right? So we would take the probability of A and add the probability of B. So in this case, I know that the probability of A is 1 over 6. The probability of B is 3 over 6. I would add the 2, get 4/6, and then simplify to 2/3. Again, you could turn this into about 66% or about 67%, or 0.6 repeating, whatever the case is, whatever your teacher prefers. I think all of these possible answers are totally acceptable. Now, the reason why this problem is very similar to the first type of problem that we did versus the second type of problem is because in here, 6 only shows up once. So we don't really have to take it out, right? If in here they gave us that the probability of A is rolling a 2, right? Then we would kind of say, oh, you know, we really have to take away that 2. Because we don't want to double count it, okay? Okay, so now let's go ahead, let's go back to this word problem. I'm going to read the word problem directly from the book, because I have it on my screen over here on the other side, but you guys can't see because, you know, it is what it is with video recordings. But this is the actual question that they're asking me, okay? So they're telling me of 162 students honored at an academic awards banquet. So I know one piece of important information is that there are a total of 162 students. Okay. 48 of them won awards for math, and 78 of them won awards for English. Okay. There are 14 students who won awards for both math and English. Okay. And then a newspaper chooses a student at random for an interview. What is the probability that the student interviewed won an award for English or math? Okay. So when we're looking at that, English or math, we know that we're looking for the probability of A or the probability of B. Now, in this case, let's call math being the probability of A, English being the probability of B. And this is kind of like both, right? So ideally, what we're doing is we're finding the probability of A, finding the probability of B, and subtracting the probability of both. So I know that 48 out of 162 students won math. I'm going to add the 78 out of 162 students for the English. And then I'm going to take away the 14 out of 162 that won both. The ones that won both, those are counted in that same bit, just like they were in the second problem that we did. So for example, in this problem, my face cards and my hearts were counted twice. So we need to get rid of those extra ones. So in here, at some point, yes, 48 won math, yes, 78 won English, but there are in there 14 students that won both, right? So we want to remove that extra double counting. We don't want to have that double counting. So this is actually 112 out of 162. And then when we simplify, we just take half of it. We take 56 and 81. And that's as far as it goes because the factors are 7 and 8 and then 9 and 9, which there's no common factors. And so we're done. Again, if you really want to simplify this or maybe not simplify was not the right word, maybe convert it to a decimal or a percent, you can. So this would be 0.6914 or 69.14%. And again, this is all like about that amount. And it really just depends on what your teacher is looking for. You know, I've had some teachers who are very adamant it has to be a percent, some who are very adamant it has to be a decimal. I think all are totally fine. And if you've ever met me before, and if you've ever taken any of my classes, you know that I'm a big supporter of fractions. And so I would say fractions are the best, but you know, it is a probability type of problem. And usually probability is exposed and explained using decimals and percents. So I can see both ways. All right. I hope that this was super helpful and I will see you in another video. Bye.